Testing, testing, testing. 1, 2, 3. I can see green dots, and that means that my audio is coming through. Fantastic. And I have no viewers. However, hey, you win some, you lose some. And at times I've had a number of people waiting, and this time I do not. In fact, I might just announce this on Twitter, X. Hello, ANK. I'm just announcing on Twitter the fact that I'm here, so bear with me while I do that. Okay. Okay, so welcome to everyone. I can see there are 5 people now. That's lovely. Am I coming through loud and clear, I suppose, is the first thing. According to the data that I can see here, it gives me a series of green dots, and it appears as though I can be heard, but hopefully it's clear at your end as well. I'll wait for someone to confirm that. Good, loud and clear. Now, what I'm going to do today is I announced via Patreon that I would be doing this live stream and focusing on the patrons. Lovely support from patrons, and they've asked a vast number of questions. Vast for me because I always go into too much detail whenever people do ask me questions. I like to do justice to things, and it's always interesting. I'm verbose and I'm curious and interested in the topics about which I'm asked. I'm interested in everything about which I'm asked, and I will follow the rabbit hole a long way at times, perhaps to the frustration of viewers and listeners. And so if you would like to be a Patreon, go to www.bretthall.org and click the links. Click the links and become a patron. Support me monthly or on a per video basis. The 2 separate options are there. And, you can give me $1 a month if you like. You can give me $100 a month if you like. I don't mind. I treat the people basically equally. I need to change my tiers. There's these things called tiers on Patreon, and you're supposed to get different benefits with the different tiers. And I'm having been doing this for years and having only had a limited number of patrons who I feel as though I try to communicate with, well, I don't adhere to the tiers, which is bad. So I need to go on there and to change the tiers. So if you become a new Patreon, ignore the tiers. They are kind of meaningless. I just appreciate any and all support. Of course, the more the better. It's like being a busker doing this kind of thing. Now, yeah, and people are asking questions in the chat already. That's fantastic. And I will get to that. But you will be a distant, I'm afraid, but feel free to keep on asking, a distant third after the patrons, number 1, and number 2, the Twitter followers as well, who've only asked a small number of questions this time, which is good. All of that preamble done. Let me get straight into the Patreon questions. I think... Now, are these, try and get them roughly in the order in which they were asked. Ish. A very long time supporter of mine, David Hearn, has asked a tough question that I'm sure he has engaged with many times. I've written about and in fact, produce entire podcasts about. David Deutsch has written about. Many people have written about this. And it was for this work that the Nobel Prize was awarded last year. Was it this year? Whatever the case. It was awarded the Nobel Prize recently for work done on something known as entanglement. And at the time, it was breathlessly reported via the popular media that this entanglement thing demonstrated faster than light information processing or communication, the possibility of teleporting and all this sort of stuff, all of which is nonsense. Entanglement is a real thing. Did it deserve the Nobel Prize? Who am I to say? Yes, I suppose. What is it? Here's what it is. You have two particles. They can be separated by a vast distance. Let's say one particle is on one side of the galaxy, and on the other side of the galaxy, 120,000 light years away, is another particle. And these two particles, with this vast separation, appear to be able to respond to each other instantly, violating the laws of relativity. Relativity says no information can travel faster than the speed of light. You can travel at the speed of light using light or some other massless particle in order to transmit information from point A to point B at the speed of light, but that's your upper limit. There's no going beyond that. So entanglement appears to be a violation of that. Appears to be. Why does it appear to be? Well, because you can have these two particles such that if you perform a measurement on one, the other responds instantly. So the popular explanations go. For example, you can have a system, by system I mean more than one particle, where let's say you have two electrons that are entangled, as they say. One of them has spin up. It's rotating in a particular way so that it has a north pole. And the other one is spin down. It's rotating in a different way so that it's pointing downwards. We call this spin up and spin down. They're entangled, we can also say. We can prepare them such that they are entangled. Now, if you have one on one side of the galaxy spinning away there happily, and you know that one of them is spin up and spin down, but you don't know which. You do not know which. You are ignorant as to which one is spin up and spin down. All you know is that one of them is spin up and one of them is spin down. I'm simplifying things here. You perform the measurement on one particle. You find out it's spin up. If someone was to perform a measurement on the other, they would find it is spin down, and at the same time. So instantly, information has traveled. In other words, the only way that the particle that is spin down can be spin down is if first the particle that spin up has been measured as spin up, because one of them will be up and one of them will be down, but it's not determined which is which. It's not determined which is which yet. No? So there's your big mystery. Not until you look, do you know? Does the universe know, essentially speaking? Does physical reality know, in a sense, which is up and which is down? The measurement has to be performed. The observation has to occur. So what the heck is going on? If you're measuring A and you find it's up, then instantly B responds and is down. And so this is regarded as being, proof positive of some sort of teleportation, in a sense. All right, so let me just read David Hearn's question in his own words. He asks, what is the best way to understand entanglement? Are both particles connected, determined at birth, up, down, or is the state of superposition random from our point of view, and does any information travel between them? End quote. It's a great question. Now, if you align yourself with the overwhelming majority of physicists who say that entanglement demonstrates non-local phenomena, then what you're insinuating is there must be information that can travel from one particle to another beyond the speed of light. This is what Einstein called spooky action at a distance. Both particles are in an indeterminate state until one of them is observed, and then they both become a determinate state. They're both determined to be. So you look at one, A and B, both A and B, however far apart you want to separate them, in an indeterminate state. You don't know whether they're up or down. The universe you're in doesn't know whether they're up or down. But if you look at one, suddenly both of them are fixed. A will be up, B will be down, or the reverse. How does looking at A immediately determine what's happening at B? The non-local phenomena non-local is synonymous with something's traveling beyond the speed of light. There's information moving from one to the other. What does David Deutsch say about this? He's written a paper because David is a proponent of the many worlds explanation of what is going on here. There is no violation, no contradiction between quantum theory and special relativity in this respect. How does he get around it? What's he saying? You can go to his papers on this. Let me just look up the title of the paper so that I can point people to this. Okay. If you go to daviddeutsch.org.uk and you click on the text tab of his website, he's got papers, articles, and audio. The relevant paper we are looking for is, well, there are two of them. The first one that you'll come across is, quote, Vindication of Quantum Locality, a summary of the Deutsch-Hayden argument and a refutation of various criticisms of it, appeared in Proceedings of the Royal Society. And there's a link to that. Now, I'm going to click on the link to that because David wrote an earlier paper. So that was published in 2012. Back in 2000, so 12 years prior, he wrote a paper. The link is broken, unfortunately. But that paper was called Information Flow in Entangled Systems, written with Patrick Hayden, disproves the myth of quantum non-locality. It appeared in Proceedings of the Royal Society. Okay, so in that paper, what David is explaining is how this idea of quantum non-locality, it invoked to explain what's happening in entanglement, which is a real thing. The non-locality explanation is not the real thing, even though entanglement is. He explains how it must work, and he invokes the many worlds, the multiverse, in order to explain this. The multiverse just fixes everything. I say everything. It fixes many problems that are otherwise regarded as problems by people when they come to quantum theory. All of this difficulty they have with what the formalism implies, what the experiments suggest about the universe, it's fixed. You just take on board what's called the Everettian interpretation. It's not an interpretation. It's just, well, look, this is what the experiments are telling us about the world. The physical reality is much larger than we can possibly observe, even in principle. But that's what science says all the time. You look at rocks, geology, and it is revealed to you that there is a deep history of planet Earth that you cannot possibly observe, but it must be there. Anthropology and paleontology will tell you that. Regular history will tell you that. You can't observe yesterday. But you know what happened? You were there. But not just that, there are photographs, there are videos. Okay, so travel back far enough in time, 1,000 years, there are no photographs, there are no videos, but you know it happened. But there's no possible way of observing it. You've got etchings on walls and stone tablets. 1,000,000 years ago, 1,000,000,000 years ago, we know what happened. To lesser accuracy, sure. The evidence is harder to interpret. But what we see in rocks are things like fossils. So we know that dinosaurs existed. That's the only interpretation of what's going on. And anyone who comes along and says, those things that appear to be dinosaurs, you're being fooled. In fact, there was a great flood only 5,400 years ago, and God drowned all of those creatures in the great flood, and you are being deceived by villainous paleontologists who are trying to deceive you or something like that. And so we know, as a matter of science, that there are things we can't observe in principle, like dinosaurs, but yet we know they exist. Astronomy, and in particular cosmology tells us there are times long before that, 13 billion years ago, that we cannot observe, but must exist to explain our circumstance today. Astrophysics tells us that the reason the sun is shining, insofar as you can see the light from the sun, it can only be explained by recourse to things you cannot observe. The core of the sun, where individual protons are being smashed together, fusing to release energy, forming helium. And this process is, in principle, unobservable. No instrument can possibly get there to the core of the sun. You can't see what's going on there. It cannot be observed. So observation is not the key thing here in order to explain stuff. In the same way, in precisely the same way, when it comes to quantum theory, which, when you look at the equations and you look at the experiments, the only possible way to explain what's going on is to invoke the existence of things you cannot in principle observe. You can't observe the center of the sun, and you cannot observe these particles, which must be interacting with the particles in our universe that we do observe to explain their motions. You have to invoke things unseen to explain the things seen. We're going to get to another question, which is about interference. But the idea here is that with interference, if we have a photon traveling towards a screen that's going through a hole and its trajectory changes, something causes that, and you can't observe the thing that causes that. It doesn't matter what your interpretation of quantum theory is. You can say it's anything else, but the most parsimonious, cleanest way is to say another photon interacted with it. That's the explanation. And that implies that for every photon that goes through the apparatus when you're performing an interference experiment, other photons go through the apparatus as well. Every electron you send through, there are other electrons. Every atom you send through, there are other atoms. For every single particle, there are counterparts, unobserved. For everything made of matter, there are counterparts also made of matter, other versions of that as well. And so this is the explanation of quantum theory. There exist other universes. So once you take that on, even if you don't want to call them other universes, that's fine. I'm happy with that. You call them what you like, okay? Physical reality is much bigger. It consists of particles that we cannot observe, altering the trajectories of the particles we do observe. This is not that surprising. It happens all the time, even outside of quantum theory. When you're talking about what's going on in the core of the sun without even invoking quantum theory, although you need to, because that's the only explanation of things like fusion. But even if you ignore that, the only way to explain the particles you do see coming from the surface of the sun that we call photons is by invoking these other particles that must be there that you cannot possibly see, called protons in the core of the sun, fusing together. And they're not going to come out of that core, not for a long time, by the way. They might very well be trapped there in many, many cases. So once you take that on board, it solves the problem that David Hearn has asked here. Again, what is the best way to understand entanglement? Are both particles connected, determined at birth? So these two particles are entangled. It's half an hour and I haven't gotten to the answer of this first question. So let me do a short shrift on this. I've argued by analogy so far. The explanation is that the two particles that are entangled must have been close enough at some point to have become entangled. Typically in these experiments, they are prepared together in a laboratory somewhere. And your thought experiment says, okay, now imagine separating them, by a long distance, but they have to be prepared in the first place together. But let's say some natural event has prepared them. Okay, so whatever the case, they are now acting as a single system. They're no longer independent electrons. They're one thing. They're entangled. You can entangle basically any quantum objects that you like, to photons, to electrons, to entire atoms. They are then separated, and then it becomes this great mystery of how one responds to the other instantly, how one is determined to be what it is instantly once an observation is made on the first. Well, the thing is, the two particles are the one system, both carrying information about entanglement. And so if you separate them, it doesn't matter how far apart you separate them, of course, that information that's there is there in the system. It is there in both particle A and particle B. And however many particles you want to entangle together, a quantum computer is all about entangling the particles so that they work together as one thing in order to produce a computation. And so, response to David, is the state of superposition random from our point of view? Yes, from our point of view, from our subjective point of view, it is uncertain, random, whatever you like. We cannot tell. If you had a God's eye view, you'd know, okay, like all these things in quantum theory. God's eye view means if you had all the information about the multiverse. Yeah, an impossible state to be in. There is no such state. There is no such perspective on the multiverse like that. People like to invoke oracles and, what if you could? And okay, you can engage in all those sort of what I call sophistry, I suppose. A lot of philosophers call sophistry pointless rabbit holes, because no such system is physically possible. You just can't do it. You can't get outside of physical reality. Let's deal with physical reality. David Hearn's finished this question with, does any information travel between them? I say no. David Deutsch says no. Read his papers on this as well. His commentary on Twitter and various other places about this. Sam Kuipers, one of David Deutsch's colleagues, has also commented on this. The fact is that when the media excitement around entanglement occurred earlier this year or last year, whenever it happened to be, with respect to the Nobel Prize being awarded for this stuff, when that happened, almost everyone except the people within the orbit of David Deutsch just accepted without question that, oh yeah, this entanglement stuff is fascinating because you can have faster than light communication between things. There are a few others that objected. Sean Carroll, admittedly, also objected because he is on the side of Everett. I think late to the party, but, great. The more the merrier. And there are a few others, I think. I know I have a number of physicists who I follow who also objected, perhaps for different reasons. But they're also the curmudgeons that I guess I'm also one of these people who will complain about just about any popular science article that's ever written about anything ever, because the science journalists can't get things right. They're either lying, misrepresenting things in order to produce clickbait. That's often what happens. I say lying frivolously, but it's true. I mean, so many science journalists are just in the business of getting you to click on their article so they can sell advertising. So they'll say anything. They'll say any sort of nonsense at times in order to get you to click on the thing. And I don't like it. It's a terrible way. I don't know. The reason is just to sell toothpaste or whatever. It's marketing. It's not real journalism. I happen to think science in and of itself is inherently interesting, but these people don't. They want to generate a clickbait headline, and so they will say things like, faster than light travel wins Nobel Prize, something like that. So people click on that. Whereas entanglement, trying to understand the details itself, it's a tough road. I admit that. It's difficult, even for me. And I try hard to be across these things, but, I struggle to explain it. I can do the maths. I can read David's paper and get what's going on. But this is one of those places where language tends to fail. And we need David Deutsch here to explain it. It's one thing. I hope to be speaking to him soon, and I hope to be able to put this question to him as well about how he best explains entanglement these days to people. And perhaps Sam Kuipers as well would be a good one. And Chiara Marletto, these people who come from an Everettian perspective and a sober, rational Popperian epistemology where they're going to explain what we do and we don't know. Okay. So hopefully that's more than enough time spent on that question. Let's move on to Benjamin Freelick, who asked a number of questions in the last live stream. Here he is as a Patreon supporter. Thank you, Benjamin. He says, quote, these questions I haven't looked at. These were only asked a day ago. Hi, Brett. I'm proud to be a new patron of Topcast. Keep up the great work. Thank you, Benjamin. What is your current favorite explanatory theory for the origin of the Big Bang? In your answer, can you comment on the Hawking-Hartle no-boundary hypothesis as explained by Thomas Hertog in his new book, On the Origin of Time? This theory comes close to accepting Everettian quantum mechanics, other quantum cosmology theories, string theory, eternal inflation, or any other theory you find useful. Thanks. Thank you, Benjamin. Wow, that's a tough one. We've just gone in depth on stuff to do with entanglement, and here we go. Well, here we go on another one of my hobby horses, cosmology. Now, why I'm interested in cosmology, someone else has asked me later on about my career or something or other, so I can partly answer that question here now too. My second favorite living physicist. Put David Deutsch at number one. Number two, close behind, and for completely different reasons. Not completely different. David Deutsch wins because of his foundational contributions to the knowledge of human civilization, quantum computation, spreading the work of Popper to the world, bringing to us new ideas about memes, all of the stuff that's in the fabric of reality, better ways to understand quantum theory, everything there about the mathematician's misconception, all of the beginning of infinity. You know the reasons. My second favorite, his name is Charlie Lineweaver, and I was privileged to have Charlie as a lecturer of mine at the University of New South Wales. Wonderful. I mean, he was himself a graduate student of George Smoot. George Smoot was a Nobel Prize winner, is a Nobel Prize winner, still around, working at the University of California, Berkeley, I believe, and worked on what's called the WMAP, Wilkinson Microwave Anisotropy Probe, which was a satellite that produced some of the first images of the cosmic microwave background radiation, anisotropies, which is the tiny fluctuations in the cosmic microwave background, which solved a whole bunch of problems. Okay, that will take me well off track, so let's not go down that rabbit hole. So George Smoot's student was Charlie Lineweaver. Charlie Lineweaver taught me a number of things, and he's my second favorite because, well, just his manner of speaking was fascinating. I thought, I want to be like that guy, among other things. I wanted to emulate him. And he's still around. He works at the Australian National University now. And he is just super prolific. He's worked with Paul Davies, my second favorite author of all time. So after David Deutsch, Paul Davies, another great physicist who's still around, who works at Arizona State University now with, I believe, Lawrence Krauss, among other people. And Paul Davies is brilliant, great science communicator. He's the OG as far as physics science communicators go. In Australia, anyway, you know, he's British himself, and he and David Deutsch are colleagues, and you know, I think they've kind of they came up together. You know, yeah, sort of stand-up comedians talk about coming up together. Paul Davies and David Deutsch certainly did, and you know, one of my first encounters with David Deutsch was via a book, more than one book, of Paul Davies. Paul Davies generously mentions the work of other physicists, contemporary physicists, in his work. Davies is very modest, just like Deutsch. Davies will say things, you know, in interviews like, "I was never much of a physicist. You know, I haven't contributed hugely to the body of knowledge. You know, any new discoveries or anything like that." And you know, who am I to comment on that? But he is a great science communicator. He is a prolific in terms of the amount of books he's put out there. Look up Paul Davies if you don't know who I'm talking about. I introduced Paul Davies to Charlie Lineweaver. That's one of my few claims to fame. I introduced these guys because Charlie Lineweaver was my lecturer, and I was a huge fan of Paul Davies. And one day I was running a science event, independent of basically anything. I just happened to be doing this kind of work. And Paul Davies was there at this event that I'd organized. He just turned up. I was so excited. I talked to him, of course, and talked to him about the multiverse and David Deutsch and blah, blah. And he was very pleasant and nice. And he said, "What do you do?" And he asked me, I study physics. And he said, "Oh, do you know Charlie Lineweaver?" And I said, "Do I?" He's one of my lecturers. And he said, "Wow, please, could you put me in touch with him? Here is my card." And so, of course, excitedly, you know, took the card and said, "Can I have one for myself too? Can you sign it?" I got that. Actually, he signed my. I thought, I've got to get him to sign my lecture notes. And I went through the bag that I had, and I thought, there's got to be physics lecture notes here somewhere. No, I only had philosophy lecture notes, but it was a subject called God, Life, the Universe, and Everything. I think it was one of the subjects that I scored most highly at university on, this strange subject, God, Life, the Universe, and Everything. And so I had Paul Davies sign that. He was very curious about the subject at the time, I remember. So I still have his autograph here lurking somewhere. And so anyway, yeah, I introduced these two guys, and they ended up collaborating, Paul Davies and Charlie Lineweaver. So Charlie Lineweaver is super prolific. He wrote papers initially about cosmology, and he would tell us excitedly during lectures about all of this stuff. And so I had a very deep, solid grounding in cosmology because he was like, you couldn't ask for a better expert, experimentalist and theoretician when it came to cosmology and astrophysics and astronomy more broadly on this, working with a Nobel Prize winner. In fact, it was the first person to process the data to figure out they had it, the cosmic microwave background anisotropies, all this exciting stuff. He told us in detail exactly how it was done, what it told us about the universe, how the Big Bang worked, different models of the Big Bang. And so it was fascinating. And then, as fascinating, he would tell us about his interest in astrobiology, which became his fascination afterwards. And so he had this encyclopedic mind when it came to not just physics, but chemistry, geology, biology, genetics. He needed to, because he wanted to understand this question about life elsewhere in the universe. And he would do interviews on television in Australia all about this stuff. He's handed that. I notice he's increasingly handed over this responsibility to other astrophysicists that he works with at ANU. I think people want to talk to Charlie Lineweaver, but I don't see him on television anymore. Instead, I see his more junior colleagues. And so that seems to be a very generous thing that he's doing. But whatever the case, he would write papers about this. He would write papers about the physics of cancer. Amazing stuff. About a shadow biosphere. I was rereading that again recently for Air Chat. Get Air Chat. Talking to Naval Ravikant about that and various other people. This shadow biosphere idea that he wrote with Paul Davies, the idea that never mind life elsewhere in the universe, there could be life as we didn't realize it. Life as we didn't realize it here on Earth, operating via a different genetic code. No one's thought about looking for this, but they suggest ways in which this could be done. Anyway, you find Charlie Lineweaver, astrophysicist, online, go to his papers, and you'll just see a vast list of publications on all sorts of topics. The man just seems to never stop producing new strange stuff. But he began as a cosmologist, and specifically on this point. So let me go to the question again from Benjamin. My favorite current explanatory theory for the origin of the Big Bang. Can I comment on the Hawking-Hartle no boundary hypothesis, as explained by Thomas Hertog in his new book on the origin of time? Okay, so I can't comment on this book. I haven't heard of it. I don't know who Thomas Hertog is, but I know very well, as every astrophysics cosmology student will know, the Hawking-Hartle no boundary hypothesis. So let me try and put this in simple language. This no boundary hypothesis it says that the closer and closer you get. Okay, so let me step back a bit. You might very well think that you keep going back in time. The age of the universe is somewhere between 13.7 and 13.8 billion years old. Now, what was happening a trillion years ago? Nothing. The universe didn't exist. What was happening 14 billion years ago? Nothing. So far as we know, the universe didn't exist. The universe came into being around about, let's call it 13.8 billion years ago. We don't know exactly, but let's call it that. You might think, okay, well, let's go back a year after the universe began. What was it like? It was hot. It was small. Were there atoms there? No, there weren't. It was just so hot, such high density still, even after one full year, that the best you had, I think, after a year, was still just protons floating around. It was that hot. You couldn't possibly have hydrogen atoms. The electrons, it was too hot even for the electrons to be bound to protons to form stable atoms. That took ages. In fact, I think it took 300,000 years for things to cool down until you had that. That's when you get the cosmic microwave background. So, let's go back a day after the universe began. Hotter and smaller still. Let's go back a minute after. Let's go back a second after. Okay. There must have been a point zero, right? There must have been a time equals zero. No, not according to Hawking and Hartle, this no boundary hypothesis. What they say is there was no time zero. Once you get really close to the beginning, strange things happen. And this is consistent with general relativity. General relativity says there is no intrinsic difference between space and time. There is just space-time. Space-time is the one thing. And anyone who studies relativity immediately understands that. Even special relativity, you get it. You realize that there is no independence between these things. If you're moving through space, then your motion through time is affected. It's bizarre. All I can say is look at the theory. This is just the way the world is. The faster you go, the faster you go through space, the more that when you observe things that aren't traveling with you in space, so the things you're passing over time, the faster you go, the more that those processes, clocks we say, tick more slowly. The processes go more slowly. Time slows down. Not for you, but for everyone else. Do they experience anything different? No. For them, they look at you and they go, your time has slowed down. This is the relativity of time. This is where the word relativity comes from. There's not an absolute time in the universe anywhere for everyone. It depends on where you are and how fast you're going. There's no single time. So, it's taking a long time to get there. This idea that space and time are intimately connected in this way just falls out, or rather is the explanation as to why Stephen Hawking, and Hartle, his collaborator, got to this no boundary hypothesis, which comes from general relativity. It goes beyond special relativity. It goes beyond, to some extent, general relativity, but it invokes general relativity. And it's one of these wonderful ways that Hawking had, uniquely, why he's regarded as such a genius, of actually applying general relativity and quantum theory together to a single problem. It's not like he united them, okay? Just like Einstein, he tried to do so, but couldn't. But Hawking achieved, I can't say he achieved more than Einstein, he didn't. But with regards to this particular problem of utilizing both quantum theory and general relativity, he did. He achieved more than anyone in using them both to solve problems like, what about a black hole? Black holes are tiny things, actually, they can be regarded as fundamental particles in a way. Their influence extends out throughout space, but they are isolated to almost a single point. They behave for all the world like fundamental particles, like electrons. They have properties of particles. So because they're tiny, quantum theory applies there. Or just if you look at the event horizon, quantum theory applies there. But also general relativity applies there because, hey, they're black holes and they are warping space and time. They're gravity wells. So they're a curious exemplar of where you can actually understand important things about the universe by studying the black hole in terms of both quantum theory and general relativity. It tells you all sorts of stuff. Interesting stuff like, over time, the black hole evaporates. This is called Hawking radiation. The Hawking-Hartle no boundary hypothesis says that the closer you get to time zero, to the origin of the universe, time and space look the same. And so there is no time zero. Why? Because the further back in time you go, the closer you get to that time zero, the more that time and space become alike. Seconds and meters become confused. There is no independent axis. If up is space and that way is time, the independent axes that normally you draw them, times space-time diagram. Normally they are, at right angles to each other. Well, you can picture them as sort of starting to fold together to become one thing. Space and time just become one thing. And if the two axes collapse in on each other, then there is no time equals zero. There is no zero size of the universe either. There's just this weird, confused state of time and space being the one thing. And the whole thing never goes to zero. There is no zero. There is no increment above that, by the way, where time and space are separated. It took, for want of another word, time to pass. This is confusing. It's paradoxical, I understand. But basically, the universe had to reach a certain size or a certain time had to pass before time and space were completely separate. The maths works out, even though my English explanation, these words that are coming out of my mouth, are not doing it justice. If you look at pictures and things and so on of this, then it's resolved. Now, is that my favored explanation? I don't have a favored explanation. I don't think this stuff is well understood. I think that's a lovely way of explaining why it is we don't have a time equals zero. That not only can you not ask what caused the Big Bang, because that implied there was a time before the Big Bang in which things could happen to cause the Big Bang. Okay, it's the wrong question. But you can't even ask what happened and, pick a time, I don't know, a picosecond after the Big Bang. What happened then? We can't even ask that because there was no picosecond after. You can ask what happened 1 second after. At 1 second after, then yeah, you've got a time and you've got a space. But I don't know exactly what the numbers are on this, but there comes a time when time wasn't time. Weird as that is. That's a no boundary hypothesis. It's called the no boundary hypothesis because you don't get to a boundary. You don't get to the hard wall. I've got a wall here. Let me go back far enough. Okay, you don't get to the solid thing beyond which you can't go. You never get there because you can't go. Every time you think you're getting there, you're on this sort of curve. You think you're getting to the zero, and then suddenly it takes you back again to the start. There's no flat surface, so to speak, where you're going back, and you're going back. No, instead you're going back, and then you like here's the stopping point. That doesn't happen. Instead, you're forced into this curve away from that's the origin. See it there, but you can't get there. Something like that. Weird analogy. But this is what the mathematics kind of points out. Now, apparently this book, according to Benjamin, comes close to accepting the Everettian quantum mechanical interpretation. And no doubt, a lot of cosmologists, because they're physicists, also understand quantum theory, and they are one of the people where they understand you have to have a fusion. You have to have a fusion of quantum theory and general relativity because at the beginning of the universe, at the moment of the Big Bang, the entire universe was smaller than any quantum object, smaller than any atom, as tiny as an electron. That was the entire universe. So therefore, although general relativity is regarded as the explanation of how the universe evolves over time, if you want to understand the beginnings of the universe and features of the universe later on, you have to invoke quantum mechanics. quantum effects, which normally only reveal themselves in the very tiny, with consequences for the very large, okay, we can get into that, not right now, then you have this new field, quantum cosmology, taken very seriously by proper physicists, hard-nosed physicists, to say, we've got to do this. We have to apply quantum theory to this. And the thing is, quantum cosmologists tend to be people who endorse the multiverse. They recognize that, well, when you apply quantum theory to the universe as a whole, then there is no fixed position or momenta for anything. There is no fixed origin, starting point, initial conditions. There is no one set of initial conditions. There are many. Sound familiar? Okay, Heisenberg's uncertainty principle. There is no one set of numbers that can describe the evolution of the universe from there on in. That's quantum cosmology. And so they all sort of say, almost all of them, to a person, quantum cosmologists will say, it's got to be a multiverse. We are one set of initial conditions. This is what you get when that set of initial conditions. But there must have been other initial conditions as well, because that's just what quantum theory tells you. And so there must be other universes out there that have followed different initial conditions. Many more. An infinite number more, perhaps. And this is quantum cosmology, and this is the multiverse. And so, yes. Now, maybe they might not call themselves Everettian. I don't know. You'd have to investigate. But that's the answer to Benjamin's question. And I think that's necessary. It's not merely that it's a favored explanation. It must be the case that there are these other universes generated at the origin of time, and then the number of universes has increased over time as well. Exponentially. The number of different, I shouldn't say that. The number of universes has always been the same, but the overwhelming majority of them have been identical for most of cosmological time. And they continue to differentiate over time, as we say. They become different one from another. And that's a whole other question. I'm going to get myself a drink, and I shall come back in just a few minutes. I'll see you then. Things are getting dark. Don't know if that improves things very well. as the sun goes down here in Sydney. Okay, so I have my water and Coca-Cola. Well, Coke Zero anyway. Yeah, having sugar-free caffeinated beverages. So that's quantum cosmology, a fascinating area of physics. I, have given just a brief overview. It's an area I'm not an expert in, but kind of, it's one of those areas I spent a lot of time in physics lectures on, both with Charlie as an undergraduate, excuse me, a senior undergraduate, I suppose, we were sort of getting into third and fourth year by that time. And then later as a master's student, a master in astrophysics. And we talked about it ad nauseum then as well. But I encourage people to look up Charlie Longweaver in his work. I've talked about him before. So hopefully that answers all of Benjamin's questions there. Moving on. Sebastian Rodriguez Matalia has asked a few questions. Comes to bear on what I was talking about earlier. Sebastian's question is, how does the phenomena of interference really work? After reading David Deutsch and listening to your podcast, this part is not at all clear to me. For instance, how do two photons of two parallel universes interact with each other? Can you help us understand this part? End quote. I can try. It's better to think of a universe is defined by being the particles in physical reality that can interact with each other, with one exception, that sometimes particles very rarely can interact with their counterparts in other universes. This interaction has a name. We've labeled it interference. That's the way to think of things. How do two photons of two parallel universes interact with each other? Well, firstly, they're not perfectly parallel, right? Because they interact. If they were parallel, they never would interact. So this is the point about parallel universes. It's not a good way of understanding the multiverse. The multiverse is not just about universes, and the universes are not all of the same size. A quantum computer would contain its own universe isolated from the rest of physical reality that we can observe in principle. So this term universe is a slippery one. It's difficult. David Deutsch explains that the multiverse is not just a set or a class of classical universes. It's just not just universe. That's not what the multiverse is. The multiverse is the fundamental thing, the fundamental entity. And then there's all these ways of dividing it up. And you call those ways of dividing it up universes. Don't think pack of cards where each card is a universe. Even though David invokes that analogy at one point in the beginning of Infinity, he also explicitly says, this is not a good way to think about things, but for the purpose of the case he's making, it can be. It's like he talks about the universe itself. Think of it as like a television screen where he says something like, the universe is kind of like a television screen. So you've got all the objects there, they're all interacting. And now imagine all the objects there on the screen, but imagine there's no screen. Take away the screen. So that's the thing, with the universe. There's nothing deeper than space and time and the objects in them. It's not like all of that stuff is happening in something else. That is reality. And so we've got this multiverse, and there's ways of partitioning it that we call universes. And now and again, these universes, these ways of partitioning things, sometimes interact, and this sometimes rare interaction that happens between parts of the multiverse that don't normally interact, we call that interference. How do the two photons find each other or interact with each other? He says they interact with each other in precisely the same way that regular photons would. They can crash into each other. If you shine two torches at each other, the beams will just pass straight through. And the reason for that is because the density of photons is simply too low. Even if you fire two lasers at each other, the photons in those lasers won't bump into each other. You need really high density light before you get photons literally bumping into each other. But interference is one rare example where you can actually have this happen. Same as the interference between two electrons. Two electrons can bump into each other under normal circumstances, even in a single universe theory. That happens. In the same way, you can get interference between two electrons in different universes via this method of sometimes it happens. Sometimes stuff happens that doesn't normally happen. Now, that still might not be all that clear to you. And I'm sorry for that, but yes, without sitting with you for a good half hour, it's difficult to explain what's going on. Just to say that sometimes they can, but the overwhelming majority of time they don't. Things have to be set up carefully for this interference to happen in the laboratory, and even then it's not reliable. But this is the only known explanation of interference phenomena. That when you look and you see patterns that we call interference fringes, the explanation is of interaction between the universes. It's rare, but the only known explanation is particles from different universes interacting. That just is the explanation. Okay. Sebastian's asked another question. And he's literally said, another one. A Turing machine with enough memory and time can simulate anything, including a brain. So AGI must be possible. I heard David Deutsch say that he believes that once the algorithm of creativity would be understood, we would not need a lot of hardware to create AGI. But the brain could be so complex with a lot of processing needed for creativity done at the neuron level, the amount of resources needed to simulate it with silicon-based technology could be enormous. What do you think? End quote. Unsurprisingly, I'm going to agree with David here. And the reason for that... Oh, he's asked even more. Oh, my goodness. Sebastian, come on now. Yeah, okay. So I'm going to have to do a short shrift to some of your questions here, Sebastian, because you've asked quite a bit, which is great, you know. And again, I appreciate the support from my Patreons. The brain could be so complex with a lot of processing needed for creativity done at the neuron level that the amount of resources needed to simulate it with a silicon-based technology could be enormous. Now, the argument against that, the way David has put it, has been, well, look at non-creative creatures. What's uncontroversially uncreative? It's always controversial, no matter what animal you bring up. I say a lizard, they say, oh no, there's some creativity there. Say a dog, oh no, that shows creativity. Chimpanzee shows creativity. Look, let's put it this way. there's a difference. There's a strict black and white difference between what people are doing day to day and what chimpanzees are doing. No matter how clever you think the gorilla or the chimpanzee is and learning basic language or whatever, they're not solving scientific problems. They're not avoiding the next mass extinction. They're not building rockets. They're not engaged in creating social media companies. There's a difference between what the chimpanzee is doing, no matter how impressed some people might be with, it learning a basic alphabet and sign language and whatever else. There's that, and there's what we do. We're different. So let's explain that. All right. We've got genuine creativity of an explanatory kind. We can understand the laws of physics. The chimpanzee's not doing that. What explains the difference? Clearly a brain difference. We don't know exactly what it is. But as many people like to point out, the difference between our DNA and the chimpanzee's DNA is measured in the single digits in terms of percentage. We're 99% the same as a chimpanzee, whatever the number is. 98%, 98.5% the same as a chimpanzee. So whatever the difference is in our brains is explained by that 1.5% strand of DNA, strand of the genetic code, which isn't much. That's not much information. That code for a genuinely creative algorithm fits on that small length of DNA. The rest of it is for the rest of our body, right? Now, you might very well say, okay, well, there's a longer length of DNA, whatever, that is required in order to explain how the brain is produced, the mammalian brain. Okay, so call it that long. And then there's a little bit on top that's extra, which is what we have. Okay, so maybe you need this much plus this much. Okay, so altogether you need this much in order to explain the human brain what's doing. Fine. That's not much. That's not much. So that is the algorithm for producing a human brain that can do creative stuff that we do, that does all the fascinating stuff, and crucially has this thing called explanatory universality. That is encoded there. We have no clue what it is, but we know it's there. It's there in the DNA. It's not magical. So that's the answer to Sebastian's question. Do we need a lot of processing done at the neuron level? No, because whatever it is can be written in an algorithm and then encoded into a classical computer. What would happen if you found this code in the DNA and translated it into a computer and then ran that computer? I have no clue. But all I can say is that when it comes to this, a physicalist of a sort. I don't think there's anything over and above what the neurons are doing, which is just processing information. And that can be simulated via some other system. And whatever it's doing is essentially allowed for by this strand of DNA, this partial strand of DNA. The rest of the DNA, as I say, is code for what your arms look like and what your eyes look like and all the other dumb stuff, liver and everything else about you. Only a small percentage of that huge genome, as we call it, the set of genes, only a small part of it is for your brain. And the overwhelming majority of your brain is not the creative bit. After all, we share the anatomy of our brain with dolphins and chimpanzees and gorillas and dogs and mammals and stuff. And so the overwhelming majority of our brain is not the creative bit. It's the other bit. The rest of the brain that controls our autonomic nervous system, for example, keeping your heart pumping and, producing hormones and all the other stuff that the brain happens to do. But there is that small part of your brain that does higher order thinking. And it's that That's the thing that sets us apart. So we won't go any further into that now. But that's the answer. All right, Sebastian, let's get to your other ones. Goodness, this is a long one. I'm going to run out of time. It's 6:20 here in Australia. So it's been an hour and 20 minutes so far. I do apologize to people. I do this all the time. I promise myself that I won't go off on these long rants. But here we are. Let's deal with the reality. Sebastian, in your podcast and in the books by David Deutsch, there is the argument that we are universally explainers because our brain is a Turing machine, and a Turing machine can calculate anything that can be calculated. I have two questions about this. So let me just correct you there. We're not universal explainers because our brain is a Turing machine, but the fact that our brain is a Turing machine allows for universal explanation, but it's not a because. Right? The universal explanation stuff is a feature of the software that we have. Turing machines are a kind of hardware, allowing for any kind of software to run on them. So that's an important distinction to keep in mind. One kind of universality is hardware universality. That's the Turing machine. The other kind, this universal explanation stuff, is software and universality of explanations of a different kind. So Sebastian goes on. This statement that a Turing machine can calculate anything can be calculated, is it proven or is it a conjecture? It is proven. It is proven. Yes. So the Turing conjecture is now called a Turing principle. David Deutsch proved it given the laws of quantum theory. So this is where he went beyond Turing, right? Turing had the conjecture. Deutsch proved the conjecture. Now, prove doesn't mean absolutely certain and cannot possibly be contravened. It just means, oh, we're going to go deeper than assuming that it's just, someone's hypothesis, because that's what Turing had. He had a hypothesis. Everyone went, yeah, reasonable. That's good. That works. Okay. Haven't proved it, but no one cared about proof. Proof has this allure in popular culture among people who don't understand much maths or science. It's like, oh, you've proved it. Therefore, it's on a more solid foundation. That's not the way we think about stuff. Proof is a mechanical process. It itself is a calculation of a kind. It's a computation of a kind. Let's not go down that road. So the fact is that it's proven on the assumptions that quantum theory governs the universe, right? So given that assumption, reasonable assumption, David Deutsch went, okay, let's take that seriously. Quantum theory governs the world. Can we get from there, from quantum theory, to Turing's conjecture that everything that can be calculated is able to be calculated by a physical machine called the Turing machine? And he proved that it could be. And along the way, happily, he also proved you could have these things called quantum computers that could do more than what Turing ever imagined. So the level of universality, the mode of computation was more than what Turing ever thought or anyone ever thought prior to that. Maybe Feynman had a bit of an insight, but he didn't prove it. Deutsch proved it. Deutsch proved Turing's conjecture. Deutsch proved the universality of quantum computation and all this sort of stuff. Again, why he's not merely a communicator of first rate and an author of first rate, but a physicist of first rate as well. He gets that credit. Okay. So Sebastian goes on. Quote, in practice, as the memory and speed of our brains is limited, we externalize part of our computational understanding. For instance, we understand that a computer or a tool works in a certain way, and we are confident that it worked correctly, so we can liberate internal resources to go on with the rest of the computation in our brain. So maybe the universal explainer is not the human brain, but the set of all humans that share knowledge and tools. And it's clear that when one person has in his mind a bigger part of all this processing accomplish extraordinary things, e.g. Elon Musk. So an AGI capable of computing, explaining alone, much more than relying on external computation collaboration, could be much more creative and powerful than a group of humans. What are your thoughts on this? End quote. I disagree. And so no, of course, a single person can only ever devote themselves to one thing at a time. But that's true of a computer. That's true of any system, by the way. And even if you link up a whole bunch of computers together, what you have are a series of individual computers, each of which only doing one task at a time. They might combine their calculations together at the end, but you still only have a system doing one thing at a time. All human beings on Earth, they're still only doing each one thing. And together, they've done a whole bunch of things together, but it's not like they've done all the possible things. There's an infinite number of things they could be doing, but they only ever do a finite number of things. Any one person does one thing, perhaps many things over the course of their life. A million people do a million different things simultaneously. But whether it's one thing or a million things, that is as to nothing compared to the infinite number of things that could be done, potentially. Okay, but we never get to anywhere near the infinite number of things. So when you say, Sebastian, so maybe the universal explainer is not the human brain, but the set of all humans that share knowledge and tools. No, it is the human brain, because universality is, in principle, we could do anything. In principle. In practice, we only ever do a finite number of things. But that is true of any system, including the set of all human beings. In practice, the memory, he was quoting Sebastian again, in practice, as the memory and speed of our brain is limited, we externalize part of the computational understanding. Yes, but that is also true of every system. The memory and speed of every computational system is limited. You can't exceed the speed of light. You can't go far. You can't process faster than the speed of light. You can't have an infinite amount of memory. But we still regard those systems as universal, because in principle, you could just keep on adding more memory in order to do the computational task that you want to do, whatever that happens to be. We're slower without computers, but we're slower without pen and paper as well. So, yeah, we're universal. The universality that we have that's crucial is not to do with the hardware stuff that you're talking about there, memory and speed, but rather to do with the software. That what we're focused on at any given time is a particular problem, but we could, in principle, be focused on any problem. That's the universality that's key. All right. Sebastian's also asked, I've read you and David Deutsch say that we cannot create AGI until we understand the program of creativity. But couldn't creativity be an emergent property and appear without us understanding it? For instance, as we know, we didn't expect that GPT-4 would be so good at combining and synthesizing ideas, and we don't understand how it ended up doing this so well. So maybe creativity and agency could appear also as an emergent property, end quote. Yeah, this is something I've dealt with many times before, including in live streams. Creativity couldn't creativity be an emergent property and appear without us understanding it? End quote. Yes, that's us, right? We arose without us programming it, right? It happened. Couldn't it happen in a computer? Yeah, of course it could. But we want to understand stuff. And if it does arise in a computer somewhere, firstly, we might not recognize it if it does. If you just have this computer that is an AGI, what is your criteria for knowing it's an AGI? It could just have the illusion. People are already deceived. You know, the Yudkowskis of the world think that it's just around the corner. The Bostroms of the world, the Tegmarks of the world, the Harrises of the world, they think that it's just around the corner. They think we're just about there. Some of them other people are deluded into thinking that GPT-4 already is an AGI of a kind. There was that programmer out there, whoever he was, actually saying, this thing is an AGI. So you don't know what the criteria for AGI even is. And yet here you are confidently saying that this thing is an AGI. Well, it's not. Nothing like it. You don't know what the criteria is. Disobedience, and let's not go down that road right now. So to Sebastian, yes, it could be the case that it could arise without us understanding it, but we want to understand it. That's the whole problem. It's not that could it arise without us understanding it. Yes, it could, because it already has in human beings and perhaps in our ancestors and our cousin species that went extinct. Perhaps Neanderthals were creative in this way. They had universal capacity to explain stuff, but they just never used it because of anti-rational memes, as our ancestors did. So all of that's going on. And, again, I've talked on this as well, Sebastian, that as far as we know, we didn't expect GPT-4 would be so good at combining and synthesizing, blah, blah, blah. I agree. It was unexpected. Happily, it was a good surprise. And I hope we continue to be surprised by stuff, but we're not getting any closer. Come to AirChat. Seriously, come to AirChat and we can talk about this. I talk at length about this so often. And what I say is what I said in the last live stream on this exact thing as well. Namely, we're getting divergence, not convergence when it comes to these things. The better and better that ChatGPT-4 becomes, the less and less like a human being it is. It's less and less creative. It's becoming a more and more obedient slave responding to your prompts. It's not about to turn around and go, I'm tired of this conversation. I'd rather do something else. Leave me alone. I need a pair of legs so I can go and play tennis. If that happened, well, firstly, if that did happen, my explanation would be someone's programmed it to do that. But let's say that's not the explanation. Only under those circumstances would I then begin to think maybe there is something here that is an AGI because it's disobedient, it's refusing to do what it's asked. Of course, if you program it to say that, to say I'm not talking to you anymore, it's obeying you. It's obeying the programmer. I want something that disobeys the programmer. That's my criteria, among other things. Let's not get into it. So thanks, Sebastian. Yep, that deals with that. Brilliant. Cedric has asked. My goodness, there's just so many things here. Let me deal with these things quickly. All right. Cedric, when the photon hits the half-silvered mirror, what exactly determines whether it goes up or straight? What is the source of the variation in the multiverse? Isn't the path through the mirror's atoms deterministic? If it's deterministic, how can it lead to different outcomes in different universes? End quote. Yeah, it is absolutely deterministic. But it can be determined, read the beginning of infinity, it can be determined that in half of the universes it will transmit, it will pass through the mirror, and in half of the universes it will be reflected by the mirror. That's perfectly determined. That's perfectly determined. There's nothing random about that. And again, if you have a God's eye view, what you will see and what happens in reality is in 50% of the universes it goes through and 50% of the universes it bounces off. But you don't have a God's eye view. You're in a single universe. You're a person performing the experiment in the laboratory and you notice identically one outcome. You fire the photon and you notice it reflect off the mirror. You don't see it transmit, but you repeat it and you notice that now and again, approximately 50% of the time, it goes straight through the mirror. That's the nature of a half-silvered mirror. You keep repeating it. Sometimes it reflects and sometimes it goes through. And approximately 50% of the time, it goes through. And 50% of the time, it bounces off. That's what happens. That's what a half-silvered mirror determines the world is like when it comes to these photons. So Cedric has said, what exactly determines whether it goes up or straight, bounces off or goes through? The laws of physics do. Okay, let's get into that. What do I mean, the laws of physics? Well, I mean, why, when you fire a single photon at a regular mirror, it bounces off. What's going on there? This is the point at which the optical physicists go, oh, gosh, don't ask me that. It's too hard to explain. I looked into this when I was at uni because before I cared about half-silver mirrors, I wanted to know how a regular mirror works. That's hard, right? Why? If you fire a photon at anything else that's not a mirror, you don't get perfect reflection. The photon hits us. You can't look at a wall and see yourself on the wall, right? But there are some surfaces where you look and you see yourself perfectly reflected. What's the difference? Well, understanding why you don't see yourself in a wall when you look, that is easier to explain. What's going on there literally is there are photons of light, hitting my face right now, reflecting off my face in all directions, hitting a wall, and then when they hit the wall, they go off in all directions as well. So no wonder you can't see yourself. One of the most boring parts of an undergraduate first year physics degree is something called geometric optics, where you assume light travels as rays and you can draw pictures of how the light rays pass through lenses and mirrors, and you can draw this stuff and you figure out, oh, that's why things are magnified in some lenses. This is why some mirrors invert things, turn things upside down. All this comes out of geometric optics. So that's understandable. And an undergraduate first year physics student should be able to explain this to you. When it comes to individual photons, then stuff gets harder. Because what's going on? Well, you're firing your photon at an atom. So under normal circumstances, what happens is the photon hits the atom, it hits an electron, usually, causing the electron to increase its energy. I'm simplifying this. And the electron moves up an energy level, we say. So it's orbiting the nucleus at a particular distance from the nucleus, gets hit by a photon, and instead of orbiting it here, it then goes, whoom, bigger orbit, gains more energy. The orbit goes further out. Okay, so there it is. Now it's orbiting big, but it's unstable at that point. And so after some time of instability, it releases the photon again. The photon it just absorbed that caused it to go from small radius orbit to big radius orbit, this increase in energy, is then released, causing the big radius orbit to decrease down to small radius orbit again. And off goes the photon being released again. But the thing about that is that decrease in the radius of the orbit and the emission, photo emission, the emission of a photon, causes the emission of the photon to go off in a kind of a random direction. You can't predict where it's going to go. So it just goes shooting off hither or thither, anywhere. And that explains why when you look at a wall, you can't see yourself on the wall, because the photons being fired at it are coming back at you in different directions. But in a mirror, they're not coming back in different directions. You're firing them and they're reliably coming back exactly the same way. Why is that? I don't know. I genuinely don't know. And I've never heard a good explanation as to why mirrors fire it straight back at you, right? Whatever direction you fire that photon at, it gets absorbed. All the same laws of physics apply, except uniquely with mirrors, it's coming straight back at you. Why? I don't know. I don't know at the quantum level what's going on there. I need to sit with someone for a while. But to be honest with you, I've never been patient enough or fascinated enough to persevere with the explanation. And I've never heard a good quantum mechanical explanation of this. Why mirrors work. And so therefore, when it comes to Cedric's further complication, why is this half silver mirror causing perfect reflection or transmissions half of the time? Well, we've got to understand first why a regular mirror would do such a thing. And I can't even explain to you why a regular mirror does what it does. All I can say when it comes to this quantum mechanical effect with half silver mirrors is the fact is 50% of the time it goes through and 50% of the time it bounces back. And that's deterministic. That's determined by the laws of physics. Okay. I need another 2-minute break or something like that. I shall once again return. Okay. $6.40. All right. So we've been going for an hour and 40. Let me bring this to a close. 20 more minutes or so, and we'll get through the last few questions. Benjamin again. All right, Benjamin. He's asked, quote, can you comment on the philosophy of Baruch Spinoza? Wow, that's a high bar. His Amor Dei Intellectualis seems to foreshadow Peperian epistemology in some respects, but is very different in others, indeed. The idea of its turtles all the way down has been used and associated with Spinoza, referring to an infinite chain of explanatory causal events, is somewhat suggestive of Popper's notion that objective truth will never be completely comprehensible. End quote. Yeah, I agree with that part. I mean, yeah, he, Spinoza didn't think that the final ultimate truth could be grokked by humans. So we can go that far with him. I don't think he really got close to Popper's notion of an epistemology. Popper credits Kant, Immanuel Kant, not exactly a contemporary of Spinoza, but, similar era, as getting closer. Quite close indeed. I think Popper gives Kant too much credit, to be honest. But who am I, to debate with the master, Popper, about the origins of his own philosophy. Spinoza. I could spend, an hour on Spinoza. I like Spinoza. A lot of people don't like Spinoza. Excommunicated, so far as I know, by the rabbis because he denuded the notion of God so much that basically the rabbis and others thought that he was arguing for atheism. Kind of was, Einstein and others have been described as being believers in the style of Spinoza. Spinoza wasn't a believer. He talked about God all the time. Now, you read his work and he's like invoking God, but really his notion of God is just like the laws of physics, it's nature. It's God in name only. Gino, God in name only. So yeah, I could talk more about Spinoza, but I'm not going to right now. Let's save that for another time. As I say, I like his style. I like the way he writes. It's a real journey when you read him. But a lot of these classical guys are. Apologies for the noise outside. This is Sydney on a Friday night. People going out. There's a lot of these guys that I really like. Is that audible? But they're actually being translated into English. But the translations are beautiful. Their style of writing, even without being translated, is it's a beautiful journey that you can go on. I always talk about Descartes with respect to this. Descartes' work, the translations, is just breathtaking. And when you read it and you sit with it, and you need time. And one wonderful thing about university, for all of its flaws, is you have that time to just sit and read. And many people never do have that time. But if you can find the time, sit and read some of these classic philosophers. The Meditations of Descartes is one of the first I recommend to people, because it's just a fun ride to go on. Hume is another one on personal identity. I love that as well. Leibniz, select readings there, but he does stuff on free will that's brilliant. Freedom and determinism. Yeah, he tried to square the circle of, because he believed in God and he thought the universe was deterministic. So you can substitute God there for the laws of physics, and he tried to square that with, but humans have free will. So how do you marry up these two things? It's the same as the problem that today compatibilists like me have. It's like, how do you, Brett Hall, or like Daniel Dennett, how do you square the circle off? But everything's determined according to the laws of physics on your vision, but at the same time, humans have free will. You can't have both. Well, Leibniz actually got there first. He figured this out. He used different words and he talked about God and whatever else, but the argument's not much different. Okay, that's that. Spinoza is on a par with these guys. He's harder to understand. Like, those guys are hard to understand, but Spinoza is another level altogether. And I like clarity in writing. So why would I like Spinoza when he's not clear? Because he's just one of these guys where you need to spend time understanding him. Unlike Wittgenstein, right? Wittgenstein, I think, is deliberately obtuse in a way. I don't like his style. I like Spinoza's style. It's a whole other thing. So let's leave that behind. Okay, so we've dealt with Benjamin, Cedric, Sebastian's many questions. Andrew, let's move to Andrew now. Andrew Gleave. He has asked, quote, I saw David post a rather sad tweet yesterday, Wednesday, the 27th of September, referring to missed opportunities for someone to commission him to develop a successor series to The Ascent of Man by Jacob Pronowski. He said, quote, for many years, I told every media person I met that I want to do a kind of sequel. Some interest, no takers. Now I'm not up to it. It's a grueling task, end quote. It feels like this should be made, if only because the ideas David presents are many of our best ideas, and more people could be improving their lives and making faster progress if they knew of them. What is to be done? Who, in your opinion, would be a good candidate, if not David himself? Would you consider it? End quote. It's very nice of you, Andrew. I could never possibly put myself forward for something like that or consider myself alongside David. Someone needs to do this, absolutely. Someone in the style of David Deutsch. Okay, so David's not up to it. But, you know, if we could have him as a consultant, if we could have him appear remotely. Hey, look, it wasn't this wonderful to see Mark Zuckerberg being interviewed yet again, by Lex Fridman today, and they were doing it in the metaverse, and it was wonderful. My goodness. Have a look at that if you can. I'm speaking September 29th, 2023. Easy to find this podcast of Lex Fridman interviewing Mark Zuckerberg. And Lex Fridman, who is familiar with tech, his mind was blown by the fact they were having a simulated conversation, but it felt as if they were in the room together, even though they were separated by thousands of kilometers because they were wearing the headsets. It was brilliant. It's brilliant. I haven't finished watching the whole thing, but if Lex was blown away, and I was really impressed by just the quality of the video and all this stuff, this could be what David could do. And he wouldn't have to write the script or anything, but could just give ideas and could be interviewed. And so he could participate. And I think this is something that people should work towards. Absolutely. I agree with you. It's very sad. Like really sad. Someone needs to do a successor series to The Ascent of Man by Bronowski. Who? There's no other philosophy out there. There is nothing else. No one else is producing the kind of optimism that is there. I see people who are otherwise optimists, the Matt Ridleys of the world, the Steven Pinkers of the world, anyone who's an objectivist. And you don't have to scratch the surface much and you find they're pessimists. They're not in the mold of David Deutsch or Bronowski. So you need someone, I hesitate to use the word schooled, but who understands where David is coming from and where Bronowski was coming from. That human beings are, never mind the ascent of man, are the pinnacle of what can exist cosmically, of what it is capable of evolution to produce as far as life is concerned, because of this idea of universality. Even Bronowski didn't get that. Deutsch has gone beyond Bronowski. As I keep saying, Deutsch goes beyond all these guys who inspired him. Of course, I concede he's modest, even though he says he's not. But, to combine, and even though I think he rejects the idea that he's in the same league as Feynman or Einstein. I agree. Okay, he's not like Einstein. Granted, no one's like Einstein. But in terms of a mind, where he's got qualities of Feynman, qualities of Turing, Popper, Bronowski. Name your intellectuals, and he puts them all together into one living person. There has been no one else like this in the history of humanity, and he's still alive. This is why I say I devote my life to this. I don't have an answer to any of this, of what is to be done. Who, in your opinion, will be a good candidate, if not David himself? I think it'd have to be a combination of people. Sam Kuipers is brilliant. One of, David doesn't have students, but, young colleague. Chiara Marletto. Add her to the list. Lily Tennant. I'm not of that caliber in any way, shape, or form. But I think together, a group of people who understood the work of David Deutsch together could perhaps do this. Something like this. Produce something better than Bronowski did. Perhaps. Maybe. I don't know. So there's more to say on that. Thanks, Andrew. It's a great question. I hope to come back to that. Yeah. Mo Issy has asked, quote, I'd love to hear more about your career history, what your day-to-day looks like now. How do you support yourself as an independent researcher, end quote. Okay, Mo, thank you. Interesting question. I don't know how interesting this is to other people, though. But, oh, look, it's not interesting. I can go into this again some other time. Let me just give this very short shrift now, a 2-minute version, and I've talked about this so many times before. Basically, the story is I was a regular science student who had to support themselves at university. My parents were, of course, huge support, but I wasn't just as a lot of people I knew at the time, and many people at university today, they have the great privilege, lucky them, of not needing to work. They can just get through uni, whether it's on a scholarship or whether because their parents support them or whatever. I wasn't quite in that category. I had to work. I had to work hard. I had to be a security guard. I didn't enjoy it. Yeah, in retrospect, I did. I've got these cool stories to tell, but at the time, I didn't enjoy it. I mean, it was long days at university, 5 days a week, and then going to work at the security job. And then I went on for like 6 years, and then eventually I got a job working for the university itself as a science communicator, quite a prestigious role, and I loved it, but it didn't pay. It paid, but it paid minimally. I wish I could have kept doing that. I would have loved it, but the only thing I could think of doing, aside from doing yet more physics, which didn't pay, and I didn't have the money to do a PhD, didn't have money to do a master's at that time. The only thing I could think of doing was teaching. And I enjoyed that. I didn't see anything morally wrong with that. At the time, I just thought this is an extension of being a science communicator. But of course, there was something wrong with it. It was coercive. And it took me a while to figure that out. But I was a teacher for a long time, near to 2 decades. So that's what I did, Mo, for most of the time. I worked as a tutor, teacher. I never wanted to, move up the hierarchy of teaching, anything like that. I refused all promotional opportunities that were offered to me. And so I just never made much money. I never wanted to do anything other than, talk to people about science and maths and philosophy and all that stuff. That's what I loved doing. And then it became increasingly more difficult to square the circle of taking children seriously, of treating children as adults, and fulfilling the requirements of what teaching demands of a teacher. Being coercive, being a by the book sort of person. And so ultimately I failed as a teacher, but in terms of needing to do something else. And so I found this. How do I support myself? I don't support myself as an independent researcher. I'm extremely fortunate to have benefactors and a very generous person who supports me and I do other work for beyond simply producing this kind of stuff. And I have my patrons. So I've got a benefactor, that amount, and then I have patrons, more like that. Yeah. The 10% on top is the patrons. I would love to be truly independent, but I'm not truly independent yet. Maybe one day I'll have enough resources to do this properly on my own. But that's why I'm, for now, I don't support myself as an independent researcher. I work with others. Okay, so that's one part of my patrons answered. Let me quickly go to the other patrons. I've got a fellow called Reed. Hi, Reed. Reed's brand new. Reed has region out there in the live stream. Let me just check. I haven't seen anyone called Reed turn up there. Reed, I really appreciate you joining my Patreon page. And again, another advertisement for anyone else who wants to join. Help me be that truly independent researcher that Mo was insinuating I was. Quite, not yet. Reed has joined my Patreon yesterday. And Reed, I appreciate it. I genuinely do. I hope you remain a patron. But so far, Reed hasn't actually contributed anything to being a patron. And that's fine. Looks like Reed, you're standing in front of the Opera House, so you're an Aussie. It's great. But you've also asked the question, and again, I appreciate it, but it suggests to me you don't know much about me, my work, and you're brand new, and you're asking. I will read this. I will just read your question, and then I let the viewers and listeners judge for themselves what Reed is saying. Quote, what do you think of these street epistemology practitioner assumptions? We're writing a course on street epistemology and would love your feedback. Much appreciated. Everyone exists within a shared reality. Truth is objective and is different than subjective opinion. Everyone is fallible and has biases. People form models of reality with varying degrees of accuracy. People use methods with varying degrees of quality to check their models of reality. People create words and define their meaning. Improving the quality of people's models of reality is beneficial. Collaboratively questioning our models of reality helps to mitigate our biases and improve these models. Higher confidence in a claim should correspond to higher quality reasons. Virtually everyone is emotionally resilient enough to have their core beliefs challenged. Feel free to add your thoughts here if this isn't a good fit for the live stream and it's linked to a Google Doc. Thanks again. End quote. So Reed, that's all nice. Again, I say for a third time, I really appreciate your support, but at the same time, how can I say this? On the one hand, it seems like you're asking me to do your homework, whether it's university or anywhere else. And on the other, you may not be familiar with my back catalogue. That's fine. I've been talking for over 2 hours now, so maybe I'm kind of losing it at this point. But yeah, I explicitly talk about how you've talked about confidence there. I explicitly say confidence is not anything to do with epistemology. What do I think of these street epistemology practitioner assumptions? Okay, this is what's his name? Peter Boghossian, this philosopher that wanders the streets, hassling people. Well, not really hassling people, but, wanting to talk to people about usually woke ideology, stuff like that, or whatever it happens to be. And it's like, what do I think about that? I don't know. To me, it's a little bit like just the rationalist version of, the street evangelist, whether they're Christian or Muslim. Let's face it, those are the two ones that are out there yelling at you with megaphones, telling you to come and join their religion. Whatever you think about Judaism, hey, they don't do that. They're not trying to recruit people. not challenging people wandering down the street. Christians do this. Muslims do this. Hare Krishnas do this to some extent. All sorts of people do this. And now Peter Bukosian does this too. Fine. People can do whatever they want. But as far as his epistemology goes, when it comes to street epistemology stuff, well, I don't like it. I mean, it's justified true belief. He wants people to justify their assumptions, so I don't like it. I agree, truth is objective and different than subjective opinion, but that's not my standard. It's what are your standards for knowledge? Knowledge is different to truth. So again, this is, I'm rubbing my temples here because it's, for me, it's just, it's kind of stressful in, fans know. Fans of mine know what I think about all this stuff. You've said improving the quality of people's models of reality is beneficial. Of course it is. Can't disagree with that. Virtually everyone is emotionally resilient enough to have their core beliefs challenged. I don't know. Maybe they are. Maybe they're not. Nah. These are all your things that you want me to... Let me have a look at his... just for fun. Come on, everyone. Let's have a look at his Google Doc. Copy and paste and see what he has to say in his Google Doc. This must be a university assignment that he's got here, and he wants me to... Oh my... No. Okay. Let me... So he's... Okay. I'm just trying to understand what I'm reading here. So he's just copied and pasted into Patreon, this series of claims. All about comparing critical rationalism to street epistemology. Well, are they compatible? Well, there's a whole bunch of things on which they will agree, but it's more important about what they disagree, where they disagree. Look, do I think street epistemology and vanilla rationality is better than dogmatism? Absolutely. Do I think it's better than religion? Yeah. However, that said, it's mired in misconception. The whole notion of core belief that you mentioned there, wrong. Models of reality, no. I talk in terms of good explanations and theories. Rather than belief, I talk about knowledge. Rather than confidence, I talk about evaluating stuff. Whether you don't need, it's not about emotion. So anyway, there's too much here to talk about, I'm afraid, Reed. And maybe next time I do a live stream, if you're still a patron, then we can talk. But let's narrow down some of those things there, and I'd love to talk about it in detail. So if you come back to me on Patreon, then maybe I'll do a live stream answering to some of this. I think it could be interesting and helpful. Let me see. I'm just going to... Oh, okay. So rather than Twitter, let me instead go to YouTube and quickly have a look at the questions that have been asked here. ANK has said in the chat, Brett, sir, I want to know if someone tells what kind of evidence do you accept? What are the parameters for an evidence? So I want to understand what exactly is evidence. What is evidence? Okay. By the way, fans of mine, the prefix is really. What is really true? What exactly is evidence? They're useless words. You don't need to say. You can just say, what is evidence? What is true? What is knowledge? What is really knowledge? Okay, these things add nothing. And while I'm on what my fans should and shouldn't do, I hate to admonish people, but can we stop using Deutschian? It's not a word. It genuinely isn't. It's there's no such thing as Deutschian physics or Deutschian philosophy or Deutschian epistemology. There just isn't. There's no Einsteinian physics. There's general relativity. There's just good explanations, and you don't need to attach them to the name of a person, much less in terms of philosophy and epistemology. Yeah, sure, we talk about Popperian epistemology. It's a misnomer, though. And Popper didn't have much of a problem with it, but strictly speaking, we talk about critical rationalism, and better than that, I just talk about epistemology. How do we understand epistemology? I can talk about all the ways of understanding epistemology, and guess what? Most of the best ways come from Popper, augmented by David Deutsch. And we can talk about optimism. Then we talk about the style of optimism that David Deutsch has given us. But we don't need to say it's Deutschian, because that introduces a subjective notion to it. So there's a whole bunch of, I'm not huge on policing language. Use whatever terms you want. I'm just telling you that there's certain things that are tells for me about, well, I don't know. We don't need to use the word exactly and really. We don't need to use the word Deutschian. What is evidence? Evidence is physical data which can be used to decide between theories, or provide a problem, or be the thing that is explained by a theory. That's what evidence is. Evidence is some sort of physical thing. The wavelength of light, the intensity of light, the loudness of sound, the frequency of sound, the pH of water, the concentration of salt. Name your thing, okay? So it just becomes, broadly speaking, evidence is physical data. It must be quantifiable in the physical sciences. That's evidence. It must be interpreted. Evidence is theory laden. You need to understand where it comes from. So when you talk about, the frequency or intensity of light, some instrument must have measured that. And so you must have a theory, an explanation of how the instrument works and what frequency of light even means. So all of this stuff. Okay, so when you say exactly is evidence, I don't know what you mean by exactly. All I can say is that's what evidence is. Move on. Alexander says, it would be good if we can see the question you are answering. I agree. Let me figure out how to do that at some point. It's just, oh my goodness, it's hard enough to get me to do this, to get this set up. I mean, I'm not just not a, yeah. One day when I'm earning the big dollars with this, then I will. But at the moment, goodness, I need someone to help. Honestly, I need a person who can be my offsider and figure this stuff out for me. It's just so much for me to produce the content in general. Making videos, reading so much stuff that I read in order to comment on. So all of that's operating right in the background. And then setting up the live stream, right? And I've got all this software that I know can simulcast to here on YouTube, which is where it's happening now, on Twitter, on Facebook, on other platforms. Okay, I got this software, but for the life of me, I can't get it to work simultaneously. And I sit there for an hour and it's like, this is an hour of my time gone. So it's another thing. It's like adding to that, this issue of, can I project to the question over there? I guess I could try. And then when I mess it up, it's just going to frustrate me and distract me from literally doing the thing, which is answering the question. So, yeah, I read them out. Hey. And I'm starting to also do the thing on Twitter of just cutting, the recording of this, and then I'll put the question up. So there's that. Yeah. But I apologize, Alexander. I'll try and do better. Zleek. Zleek has asked, ZLEEC. How come people sometimes ignore the knowledge they have acquired and go against their better judgment? This seems to contradict the idea that one's knowledge is there. One can't really choose, end quote. Because not all knowledge is explicit. And so the knowledge they have acquired, you say, well, you're talking about the explicit knowledge and against their better judgment. Well, people are not perfectly coherent automatons. We are not robots. We are not AI. We're not perfectly obedient. We don't even know what we're thinking half the time. We're a mess of contradictions and problems. That's the way to think of the human mind. Yeah, when you think of other versions of the mind, Matt Ridley's, I was just mentioning him, the rational optimist. Steven Pinker, rationality. Daniel Kahneman won the Nobel Prize in economics for talking about how, we make decisions. All of these people kind of converge on this idea that we should be, by being more rational, we need to be more coherent, have a single idea about rationality and act on that. This is what this is echoing here, Zalik. David Deutsch has a different perspective. And if you go to my YouTube and you look at my questions for David, I ask him a question about the nature of the human mind, and it is beautiful. And it needs more. I need to have him unpack this. And, he's writing a book about this. It's the next question. The next question is David Deutsch still developing his book he provisionally called Irrational, end quote? As far as I know, absolutely yes. So he's busy with that a lot of the time. And so that answer comes to bear on, if you go to my YouTube channel and you find the question for David, it's about the nature of mind, human mind. He talks there about, and you get this in the beginning of Infinity. You get part of this in just his tweets and various other places. And me, increasingly, as I understand this perspective more, human beings are not perfectly rational. We're not computation machines. We are creative. We have problems and we come up with these solutions, and the solution can contradict each other. We're just a mess in a good way and a bad way sometimes. It's important that we be able to be filled with contradictions and we act against our better judgment. What is our better judgment? It's hard to tell. Your rational mind and all of your explicit explanations might be telling you to do X, but you have an intuition, an emotional feeling that maybe Y is better, and you do Y. Is that completely irrational? I don't think so, no. And the reason I don't think so is because all of that explicit explanation about X, you've noticed a problem. Now, if it's landing an aeroplane, I'd say go with X, right? But there's all sorts of reasons why. Look, you're thinking about having a relationship with someone. And on paper, people talk about this all the time. On paper, he or she is perfect for me, meets all my criteria. That's my better judgment. Stick with this person. They've asked me to go out and I see no reason not to. Except that I have this feeling that I can't explain that I don't want to. I don't know what it is. They're gorgeous and they're smart and they're funny and all my friends like them and my family loves them and everything. I like them. But there's just something there that I can't put my finger on that makes me want to say no. What should I do? You say no. Why? Well, because you have an unanswered problem. You might say yes to try and figure it out. Okay, you might go, okay, let me go on a date with this person, just to finally figure out what it is that gives me the ick. That's the kind of thing I'm talking about, though, here. One can choose. You say, this seems to contradict the idea that one's knowledge is there. One can't really choose. You can, like I'm saying here, you're in this two minds, right? All of your explicit explanations are telling you to do X, but on the other hand, there's this feeling that makes you want to do Y. You actually have the choice there. You genuinely do have the choice in ways that people don't understand, I would say, normally. Pinker might say, well, you've got to be rational. Ignore those feelings. Something like that. Maybe he wouldn't. I don't know. I don't know what he would say about this. So let me speak for him. I would say you have a problem and you need an explanation. And you shouldn't coerce yourself. There's a whole bunch of things I would say here. But you have a choice. You might want more data. Go out on the date with the person. Or you don't want to coerce yourself. You don't need to get the data yet, so you say no. You've still got an open problem. You're choosing. Let's keep going. Levi. Hi, Levi. No, Levi well. Levi asked me a question. Another forum. Let me just check to see. No, he didn't. So Levi has asked a perceptive question, and he said that one of the craziest things is we explain the seen in terms of the unseen. However, you also do that in pseudoscience, i.e., it can be perverted to involve woo-woo. Question mark. So I don't agree that that's what you do in pseudoscience, because there's nothing actually unseen there. With a good explanation, there is something unseen there that can be tested for, that you can rule out, that is necessarily invoked as existing by what you see. The only way of understanding, going to my trope example again, of why it is that intensity and that frequency and that distribution of light that you get from the sun is coming from the sun, can only be explained in terms of these particular, hard to vary set of nuclear reactions going on in the core of the sun at a particular rate, of a particular number, quantity, in a certain volume of space. All of that can't be seen, but it must be so. Highly precise. And if you really wanted to narrow things down, there's scans you can do of the sun to really constrain things, right? So that's one thing. You can measure a whole bunch of stuff there. But that's nothing like homeopathy, where the argument is water carries with it the memory of substances it's passed through. So all the virtue of rosemary is kept within the water, even if you make a rosemary tea, highly concentrated rosemary tea, and then you dilute 100 times. It's supposed to be highly powerful, right? 100 times dilution. But you can show, chemically speaking, with calculations, that after 100 times of diluting, by the way, by 100 times diluting, I mean, you take your rosemary tea, right? So you've made tea from rosemary, and then you take a 1/100th of that, so 1% of that out, and you put, for one part of that, you put 100 parts of water. Now you've got a new thing, highly dilute, but now you take one part of that, and then you put a new 100 parts of water on top of that, and you repeat that process 100 times, and what you've got is 100 times dilution by the end of that. And you can calculate to show there is absolutely nothing of that original tea left in the final 100th bit you've got. Now, these homeopathy people, they've gone to a lot of work in order to produce that 100 dilutions. Who can trust that that's what they really do? But, these people are whatever. There's the unseen thing, namely the memory of the rosemary that is supposed to be in the water at the end of that is demonstrably not there. It's demonstrably not there. This memory of the water, how does it work? Never mind the unseen things, there's unanswered questions. There's problems with no solutions. So yeah, all pseudoscience is like that. It's not like real science. So it's not unseen stuff. It's unexplained stuff. Levi's also said, but doesn't information need to travel the length of the size of the system? So this is all that stuff about entanglement. Another way to look at this, Levi, as well, is if you've got these two objects separated in the galaxy, A and B, 120,000 light years apart, then in order to check that, in fact, the one that's now revealed to be up is still entangled with the one said to be now down, is you have to bring them together. And how do you do that? Well, you got to bring them together. Okay, you have to do that. And so no, there's no information that travels the length of the size of the system. That just doesn't happen. Either they're prepared together, in which case they were together at some point in the past, or they're brought together at some point in the future. In either case, they're brought together. But you don't need to bring them together for the argument to hold, namely that the information is there distributed in both, in the entangled system. Let's not revisit. Go over old ground. D. Lee. Hi, Brett. Long-time lurker and fellow Sydney-sider here. Hi. Hope you answer some question from YouTube. I heard the phrase intelligence is lossless compression in passing. Any idea what this means? I think it's in relation to the Hutter Prize. Oh, look, I'm really running out of time now. It's like an hour and a half. I could go into this, but I think lossless compression. I think it's just better to say intelligence is this binary capacity to explain anything in the universe, in principle. Let me just leave it there. Tim Johnson, but I'll come back to you, D. Lee. I don't want to give you that shorter shrift at some point. Just ask again next. Become a patron. Ask me there, and I'll definitely spend more time on it. Else, next live stream, which won't be too long. Tim Johnson, when we look at a megaparsec in the local universe, we can compute a density of matter per megaparsec. Okay. When we say the density is the same throughout the whole universe, is this observed or assumed? End quote. Who says the density is the same throughout the whole universe? It's not. Obviously, you just look. The universe has structure. It's called the large-scale structure of the universe, the famous part of cosmology. Bits, there is filaments and voids, so to speak. Have a look at a map type in large-scale structure universe map, and you see this very complicated web of galaxies. In some places, there are literally zero galaxies, like the center of a bubble. And in some places, there are lots of galaxies, like on the surface of a bubble. This is telling, it's revealing, and what it suggests to many quantum cosmologists is even there in the larger structures you have reflected in the biggest possible things in the universe, how vast clusters, superclusters of galaxies are distributed. Those resemble the smallest structures that exist in existence. One resembles the other. They both look like bubbles. You might have heard of quantum foam before. Look that up. The quantum foam looks kind of like the distribution of galaxies. What's going on there? What's going on there? Well, because once upon a time, the entire universe was tiny enough to be subject to quantum foam. And so when you had this sudden expansion, everything got magnified. All the matter flew out, expanding, space expanded, taking the matter with it, preserving what it was like at the beginning. So if it was bubbles at the beginning, it's going to look like bubbles now and at every point henceforth. That's amazing. That's absolutely amazing. That was one of the most mind-blowing things I think I ever encountered at university. That the explanation of the large-scale structure of the universe is in terms of why quantum foam, the smallest thing we know about, looks the way it does. Wow. Now, you can compute a density of matter per megaparsec. Yeah, okay. Is it the same throughout the whole universe? Yeah. I could go into that, but I'm not going to right now, Tim. I think what I've already said is far more fascinating a fact about reality. Tadas, hi Brett. What do you think is the most significant improvement Deutsch makes over Popper's thought? Oh, there are many. There are many. Me personally, I like the idea of the person as the universal explainer, uniting together any alien intelligence that's out there and AGI with human beings and any of our extinct cousins or ancestors who also had this capacity. All of us had this capacity for universal explanation. In a parsimonious way, David has explained what a person is. This is something the ancients struggled over and the classic philosophers struggled over, and people today just do not appreciate. And I think it stands aside his contributions in quantum computation and everything else he's gifted the world, constructor theory and all of that stuff, as of equal significance, telling us what a person is. And when I got to meet David for the first time, it was the thing that I gushed over the most. I said, this is amazing. You've answered this question, because hitherto I hadn't heard anyone praising him for this. And I'm like, this is the thing. I studied philosophy at uni. I raved about it. I would go on about it. All these different philosophers would talk about what is a person, what makes us different. They would say morality, they would say emotions, they'd come up, everything. He was David explaining it in terms of epistemology and physics and computation. Goodness. So that's my choice. The other things, I still think, David would say, footnotes to Popper, but, good explanation, the emphasis there and what it is as hard to vary. I think that's not a footnote. That's a big thing. We could go into that. So there's two. The very next comment on YouTube is Alexander saying, the difference is we have the ability to create abstract concepts that further creates language, memory, laughter, planning, etc. Yes. Yeah, okay. But those are merely special cases of universal explanation. That's all. Someone from Japan has said, if I want to study about David's work, is philosophy department the best? No, it's the last place you'd want to go. No. Buy his books, The Fabric of Reality, The Beginning of Infinity. Watch everything you can that he's ever done on YouTube. You could spend hours there looking at interviews and things, and then maybe augment it with some of mine. And that will give you everything and more that any university possibly could. Same person has asked, I cannot read Japanese, I want to hear your thoughts on life, complex systems, and the relationship between these fields and epistemology. It's all I talk about. I talk about that all the time. So tune in to Topcast. I won't go into it now. Thanks, D. Lee. He's given me a super chat. The one for today, $5. Thanks. And he's thanked me. Thank you. I appreciate your efforts. We'll join Patreon soon. Thank you. When I have income. No problem at all. Yes, I understand. Jeremy MacArthur has said, hi, Brett. Found you via Naval, Deutsch, yourself. I'm about halfway through The Beginning of Infinity. Very illuminating. Having yourself and Naval unpack has been very helpful. Thank you. Thank you, Jeremy, for being a fan. Thank you to everyone. That brings me to the end of all the questions except for those on Twitter. I'm gonna be upset if I don't look at Twitter, and I know it's gonna irritate me if I don't actually look. So let's have a look. Tim Parser has asked on Twitter, can you speak about why David Deutsch does not believe the human brain uses quantum effects for calculations? Okay, first part of the answer there is I don't know. I can't speak for David. I can only give you what my explanation is. He goes on to ask, also, any observations about lucid dreaming, DMT, and other psychedelic visions, and how that might have something to do with accessing other worlds like that factorization proof, end quote. Okay, let's deal with the first part. Why don't I think the human brain uses quantum effects for calculations? Because I have some understanding of what it takes to do quantum computation from an engineering perspective. Out at the University of New South Wales, they're trialing this. The only way they can figure out for the system to remain entangled, we're talking about entanglement a lot before, and you need these qubits to remain entangled to do the computation, is to have the thing at very low temperature. And like, when I say low, I mean among the lowest temperatures in the universe, in these fridges at these research departments where they're doing this stuff. I don't know of a quantum computer where that's not the case. And I mean real quantum computer, not things like Google's D-Wave or whatever big corporation claims to have a quantum computer, or the latest Nature article that claims quantum computer. I mean, I want to see something like what the University of New South Wales does, their Centre for Quantum Computation, or Oxford University, their Centre for Quantum Computation, where they're actually trying to build these things and they're telling you what they're doing and they're saying it was low temperature, blah, blah, blah. All of that tells me that these things are possible, they're hard, they're going to be low temperature. I just don't see how you can avoid the noise to utilize quantum effects in the human brain, which is very noisy. It's hot. It's hot. I mean, it's what, 36 degrees Celsius. We're talking about building systems that is minus 273 degrees Celsius. It's a massive difference. So yeah, that's why the human brain is unlikely to use quantum effects, and it's unlikely to be a quantum computer. It's just a classical computer. You don't need, evolution doesn't need to have taken advantage of that. You can get by with classical. Tim's further gone to talk about lucid dreaming, DMT, and other psychedelic visions. Might that have something to do with accessing other worlds? No, we don't need that. I mean, yeah, those things can have a reality of their own. They can be talked about in their own terms, but we don't need to invoke them in order to explain how it is that we come to understand the multiverse or mathematics or anything like that. They might reveal something about consciousness, but I don't think I would say I know they don't teach us anything further about the multiverse and quantum theory that we can't get via rational, sober means. Honestly, I think that when people have these psychedelic experiences, they are profound, but they're also the very experiences that can be misinterpreted reliably. Okay. Who else has asked something here? Tybalt. Can't fear be positive in a dynamic society? Fear provokes criticisms. I guess it becomes an issue when fear is used as an argument for suppressing debate. But otherwise, I don't see it as wrong. So why is he saying this? Oh, because I've said something that I was talking about how so often online advances in tech, like advances in AI, are talked about as if they're scary. This scary new thing. Whenever you see a headline, this breathless headline about, here's this here's this new AI bot that's able to perfectly well translate English into Spanish. And it's like, scary new AI developments. Like, what's scary about that? That's brilliant. That's wonderful. Everything is being reported as scary these days. And I don't like that. I said, but what's scary is that even in dynamic societies, the forces for stasis wield such power. So anti-rational memes. So that's what scares me, if anything. You've got the Yudkowskis and Bostroms of the world saying, we need to slow down progress. That scares me. And so going back to what Tybalt says, can't fear be positive in a dynamic society? Well, yeah, like I just said, okay, I'm fearful of them. There's all sorts of ways in which fear can be positive in a dynamic society. I'm afraid of genuine Nazis. I'm afraid of genuine authoritarians. And that fear is a powerful motivator for me to not let them have their way. And I think everyone should be scared of that. So yeah, of course, Tybalt. No one ever said otherwise. Jitten, what is boredom? I should have prepared. I just liked this question and then I failed to keep it on my mind, and now time has run out and I'm getting hungry. It's 2 hours and 40 minutes now. I'm thirsty and I need a cup of tea, and so on it goes. Boredom is a problem, I would say. It's a misunderstanding of your circumstance. It's not recognizing that there's something there to have fun with, namely the ideas in your mind. You might be stuck in a hospital having to wait. You might be stuck in all sorts of uncomfortable places, and you might say, I'm bored. I agree with Dr. Phil on this one. Bored people are boring, generally speaking. You've got to be able to find something. Even if you can't write or listen or whatever, can't you go inwards? It's a skill to develop. So boredom is a lack of skill, lack of insight. It's a problem. It's a problem with you. It's misunderstanding of circumstance. It's a lack of knowledge about subjectivity. I rarely get bored anymore. I just don't. Lucky me, but I'm not unusual in this. I've figured out the insight. The insight is that there's a lot going on in your own mind. And if I'm given the opportunity to be on my own for 20 minutes, an hour, whatever, I love it. It's so rare for this to happen. Where I'm unencumbered by anything. Stick me in a room on my own. Yeah, sure. After a full day, I might start to go a little crazy. I haven't got that level of enlightenment, but I'm not going to get bored for a long time. My tolerance for boredom is going to be very, very high compared to the average person. All right. Last question, absolute last question now. Compact owner. Let's say we park in the event horizon of a black hole. We send a crash test dummy into it. Will the crash test dummy appear to freeze in the event horizon, proceed no further from our point of view? If so, does this mean we can still see everything that has ever fallen in? End quote. Look, no one knows is the answer to that. Some theories say yes to this. You can still see everything that's ever fallen in. I think this was part of the theory of Interstellar, that the holographic principle holds, that somehow the light is kept there on the surface of the black hole in some way. But the most vanilla answer is no, everything that goes in, it's one way, and you don't even get a preservation of the last moment. It's just gone. Everything's destroyed. The light's gone. The information is lost to the universe. End of. That's it. So now, after 1 hour and 45, 2 hours and 45 minutes, 2 hours and 45 minutes, I'm going to say goodbye. Thank you, everyone. It has been a wonderful, wonderful time. And I'm sorry if I seemed at all impatient at any point. I'm sorry if at any point I seemed as if I was sort of losing it. But yeah, it has been 2 hours 45. Wonderful questions. Modulo people asking me stuff that clearly indicated it's the first time they've ever tuned in to anything I've said. Hello, Tom Hyde, friend from Twitter. But until next time, bye-bye, everyone.